Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Kirk Gray.
And this is Fred Schreckberg. Hey, Kirk.
Hey, Fred. Good to hear your voice.
Yeah, it's been a little while.
Uh-huh.
You know, one of the things, we were chatting like we always do to get started. And I thought, connectors are underappreciated, troublesome little component, and cables to a larger, associated with that.
Right.
And part of it sparked is like, somebody asked me, so how do I get a job at NVIDIA to work at, or a company like that that's working on the bleeding edge, high tech and really cool stuff? And they're like, you can make a whole career just working on capacitors. But they're not fun. They're like, if they don't work, it doesn't matter what kind of whiz bang thing you got at the top end of the system. If they can't be supplied with good power, then it ain't gonna work. And then it made me think of connectors, and it's like they're a marvel that they work. To me, I run into so many issues with connectors and so many people, and it's part of an afterthought. It's the mechanical guys say, we've got to put it here so we can route cables or it has space. And the electrical ones are like, well, it's got to be where I can actually run, a circuit board, connect to it or stuff. And if you use through hole, it takes a lot of real estate. So I don't like those. And there's so many options for connectors.
Oh, yeah. Locking and keyed.
Zero insertion force.
Zero insertion force. We've seen certainly the evolution in USB has been pretty dramatic, from Apple's Lightning and C, Mini C.
Yeah, and A. Whatever happened to B connectors? I don't think they ever.
That's a good question.
But there's like round connectors with pins and connectors. One of the things I learned early on, I was working with the team, and they said, "Oh, we need 28 connections on this cable, this connector," and so they went to one of the connectors, to remain unnamed vendors, and they said, "Yeah, we can make that." And they took a 14-pin one and just doubled it. They just took the CAD and said, "All right, stick it on the side here." It never worked. They didn't take into account in the design the thermal expansion. So it was constantly moving back and forth sideways because of its size on the ends. And so the last four pins on either end of the connector were very intermittent. If the system heated up a little bit, the thing expanded. Now we didn't have any contact. And I said, "Do you make 28 pin connectors like in this style very often?" "Nope, just for you. We'll make anything you want." and did you evaluate it for this phenomena? And they're like, "No, you're the only one that has that problem. It's not our problem. It's what you asked for."
No, you didn't ask for that. The one requirement was all the pins have to be connected in operation, even when it heats up, at a certain temperature range.
But nobody asked for that. It's just that we have a spot here where we're going to have 28 pins and we need a connector for it. If we do two connectors, it takes more space. You separate them slightly. And we don't want two cables. We want one cable, and blah, blah, blah. And
nobody said this is so long, linear, that the linear expansion is going to separate the distance between the two contact surfaces, and it's going to be very intermittent.
And I suspect that, an engineer at the connector spot probably would have known that. But I'm quite sure that their business model is whatever you want, and their catalog just goes on and on and on and on forever. And
but they don't say whatever you want, whether it works or not.
They say whatever you want, and they don't judge it. They they don't test it. They don't evaluate it. They say, "You want 28 pins in this style? Okay, we'll make 28 pins in this style. You pay for it." But that's what I mean, is that part of it was the connectors, like a lot of vendors, are just squeezed on how much money they're given for anything. So they don't have the deep research. They don't have the qual systems. They don't, and they've been making this style of connector in that factory forever. And they make lots and lots of 14-pin ones and 8-pin ones and 6-pin ones. And
sure.
And it's not a problem. And they didn't do an FMEA. I'm quite guaranteed of that. They say, well, what happens if we go to 28? And it just it just was, they're so quick turnaround, get the design, get the molds ready, and make it for you. And they're good at that. They're not so good at the technical feasibility of that design. And so when we found the
Oh,
issue, it
oh.
was, oh, well, maybe you want this style connector instead, which is $1 more. But
Who
it
did they
was,
suggest that, or you?
yeah, no, we said we have a problem with this one. And they
Okay,
said, oh, you should use this other technology, this other style of connector that
okay.
accounts for the thermal expansion for large, throws of an array of pins. Oh, why didn't you tell us that earlier? Well, you didn't ask.
Well,
You went on the site
yeah,
and said, I want a 28 pin.
that's a okay. It's kind of pointing fingers at each other.
Well, there was that, but it was also systemic issue is that the electrical side guys said, I need 28 pins. The
Right,
mechanical guys said, okay. And they weren't really involved with the decision to do that. They had a 28 cable, pin or wire cable that were routing around and they could deal with that. And the connector was really an afterthought. It's not quite, it's a mechanical system with electrical properties to make
right,
contacts.
right,
And I know in memory connectors, where there's a lot of pins, and if one goes intermittent, you then the memory doesn't register correctly, and it causes problems with corrupted memory and stuff like that at times in some of its scenarios.
right.
And we often think about getting gold-plated ones and stuff that have enhanced the electrical properties, the connectivity issues. It gets solved with gold plate. But as you can imagine, gold plate's expensive. So
Exactly. And they try and put as thin a layer as they can on it and get
and then
away with it.
it's porosity, and then
And
the
then it's get
thin
scraped.
layers. Yeah, then
Right.
they get scraped, and you
And
get
then they get fretting corrosion. And then when
fretting
you get
corrosion.
corrosion, you get an open circuit to that. And this was,
Yeah,
I had this happen on dim sticks, that you used
yep,
to plug into the computer
yep.
all the time. And I could get them active, and
You take them out and put
eventually,
them back in, and you get a fresh start, but the
right,
corrosion's all
right.
there still.
But you've eliminated or you've
Wiped it away briefly,
wiped it
but
away, and so you don't get to see it. Those are kind of very, very difficult ones to troubleshoot. But if you look at the edge connectors of those pins, we found out that there was either residual contamination or, such a thin gold layer that had been scraped off in almost 1 in 2 insertions, and it
yep,
caused it, and all I had to do was put in 85 relative humidity 85C and a
the corrosion would just go crazy, and you'd
yeah,
find it.
well, and in about a day, I would have intermittent memory
Yeah.
issues. And the problem was there really wasn't any corrective action except the vendor saying, well, we'll do a better job of cleaning, or we'll
Oh,
do a
well,
better job of,
they'll do that
yeah.
stuff, but then your manufacturing team says, well, is that the right one? Did I put it in? And it's only meant to be inserted once and then left alone. And they take it in and out, in and out, in and out. And they're like, just because you can doesn't mean you should.
No, it is a real limited.
The real correction is to use a different metallization on it so you don't have the thin layer of gold on the top that allows the tin to come through.
Yeah,
But that's the issue is connectors can fail mechanically, right?
right.
Just they don't attach to the board. They don't have a positive,
The
they
pin
don't,
comes comes loose in the back. The,
yeah, it
mechanic's
doesn't
holding the
attach
pin.
or when you solder it, it doesn't hold itself in place. So it's at a weird angle and it doesn't
Right,
fit in the chassis
right,
anymore. Um, the can, and it can deteriorate so that it doesn't hold its position. I've seen that happen where the
right,
polymers weren't appropriate for the environment and they just corroded away. The polymers failed, they crumbled away, which
right,
is like, why are we ever using this? And then the metal part, it's not just a piece of metal and you put two, paper clips kind of next to each other and that works, is you need intimate contact with a certain force
right,
that they actually stay in contact. And so
right,
oftentimes the metal is formed into a spring or is the force is enhanced by, say, a polymer spring.
right.
But if you have too high of a force, you can't insert the connector, the cable. You can't mate the connector because you need a machine to put them together. And
Right.
that's expensive. Um, and then some of them you go together and they basically bond to each other and then you can't repair them. The idea of a connector is you can just detach them and do repairs or replacements and stuff of the board or whatever.
Uh-huh.
But then you mentioned fretting. There's
Right.
also just, somebody puts their fat finger on it and now you have like a chlorine and other salts, then
Right.
corrosion.
Right.
Um, there's just insertion damage. There's insertion where it's not seated correctly, and then vibration pulls it apart. I could go on and
Right.
on and on.
Oh yeah, strain relief on the back of the cable in the connector,
Yep,
where the wire interfaces, cold solder joints, just yeah, it's fairly endless, and it is, on the schematic, just a line that goes from one to another,
yep,
and this circuit board is supposed to connect with this circuit board at J1 and A1, whatever,
right.
and you don't really nobody details what the interface and connectors are supposed to require. I guess power cables, they certainly have voltage current ratings and things like that are
Yeah,
important.
yeah.
But for digital signals, things like that, you're just trying to get a voltage signal from one to another. Sometimes they're shielded, sometimes they're not.
Some of them have ESD protection built right into them.
Right,
And others, and it's all
right.
trade-offs.
Depending
And
on
there's,
Right, whether a connection from the outside, external,
yeah,
or internal, because and obviously it is going to be critical for electric cars, and I think they're having a standard. You don't own an EV, do you? You
no,
don't.
no. I've heard, a lot of companies a couple of years ago said, well, we'll just use Tesla because there's more
Right,
chargers out there. And then
right.
Tesla, was it last year, said, oh, we're not going to do chargers anymore. I was like, what?
Well, they had to come up with a standard, just like we had a standard gas spout
Yeah,
for diesel and versus gasoline that
yeah,
they
yeah.
couldn't put one in. I'm guessing, obviously to come up with a standard. Now, I haven't had an EV and I don't
But I
never
get the
driven one.
impression is that that'll come out in about 10 years and there'll be a de facto standard anyway, and then they'll write it down.
Well, there must be now because there's hundreds of charging stations all
I
over
know, and there's
parking
hundreds
lots.
of adapters that you get with your car. You have a whole box full of stuff that says if you're at a Tesla one, put this on the as an interface. And
Another
I think it's
potential
getting,
layer of unreliability.
oh yeah,
Yeah,
definitely. And it adds resistance to it, so you're wasting power and all kinds of stuff.
yeah,
But I find, and then you get the high speed stuff. Those connectors really need to be designed well in order not to interrupt your
absolutely.
signaling.
Right.
And
Yeah, interconnects in high-speed computers have a significant effect on the signal quality.
yep. And so why I wanted to talk about it is, one is just awareness of all the range of issues that come with connectors. Yeah, they're on every circuit board practically. They're almost everywhere. We use them a lot. Yet
Hmm.
within your organization, if you're a reliability person, who is the overall connector person? Who knows the different technologies and where they apply, and when do I need a latching mechanism versus, zero insertion force, and what's the difference between high frequency versus, just a 5-volt line and a static line. And
Right.
what somebody needs to actually understand that, because the opening story was, we needed a connector and we needed more pins on it. But there wasn't anybody in our team in procurement didn't have the expertise on it to say, wait a second, if we thought through thermal expansion on this, and or whatever, if we're
Hmm.
asking for something, are we doing the right thing? And it could be a career for somebody in reliability engineering to just be focused on connectors, because there's enough problems with them that you could stay fully employed.
Yeah, you'd hope that the cable companies and some of these, manufacturers of mass cabling systems, um, are very good at, having some understanding of this. Now, obviously, with this connector you had a problem with, I don't know where you found the problem or when you found the problem, but obviously,
The first time we powered it
halt.
on.
halt testing would have shown that
No,
very
it was
quickly.
just the first prototype. Does this turn
Yeah,
on?
yeah,
And about a half hour
but
later,
it
it
worked.
stopped.
It worked at first when you
Yeah,
plugged it in, and
but
it
it
was
warmed
heating
up,
up.
and then it
Right.
stopped working. Yeah,
Yeah.
it was
So
pretty
it didn't
easy to
take.
find.
Hopefully, you didn't make a whole bunch of those, but now that became a lesson learned for the connector company and your company.
Yeah,
You know that you have a linear expansion that gets on such a long connector gets to be significant.
and you have the pins are very small. It was a digital line, so you don't need a huge contact area or anything of that stuff.
Right.
The issue is that it's not quite mechanical. It's not quite electrical only. Either one of those teams really own it. They both need it to show up and be where it needs to be. And there's all these other factors that go into selecting connectors. Now,
I know.
better organizations that I worked for, they have, guideline. If is think about, they had like a list. It's what is the voltage and current it's got to go. How, is this a approved one that we already use? And it was like supply chain issues. If we already use 4-pin connectors and you only need 3, get the 4-pin because it's cheaper
Right.
than stocking another one,
Right. Volume and part numbers and all the
Yeah,
other
all kinds
things.
of stuff like that. And then it kind of went down this laundry list of
Right.
things to consider. And if it's
Right.
custom, how's it qualified? Does it work in our environment? And it triggered then, reliability or quality people to step in and work with it, or somebody to deal with. Does it really work for us?
All right.
But they are complicated enough that, and I have found more and more over the years that not just connector companies, but L vendors is they don't get the margins they used to get. They have stripped away a lot of their R&D teams. They've stripped away a lot of their customer service teams, and verification validations is, well, it met the standard, kind of thing. And they move on. And then you see it where, well, where's the test results for this? And they send it to you, and it's for the 14-pin connector. It says this is a 28-pin connector. Same family. We do the qualification on the 6-pin ones, and it should work for everything. Like, okay, I see where the problem is. They don't make enough money to test every variation and verify every
Well,
issue.
how much responsibility? I mean, you're talking about connecting something in your system, either
Yeah.
or if it's outside. I mean, if it's standard power plugs, okay, you've got the uniform uh,
Well, there's
115
there's
VAC
yeah, there's
plugs
different
that
UL criteria,
right, and there's
CSA
just
criteria.
right, and there's no need to that's kind of a commodity that's pretty high volume and all
Well, it's
that.
kind of a commodity until you start looking at the strain relief on them.
Yeah,
Then they get very different. And then
they
the
can.
quality of the manufacturing does really make a difference for the longevity of them. They're all safe. They all pass the Megger and
Oh,
all that other
sure.
stuff.
Right.
But for your application that has a lot of motion, you need to pay attention to strain
Right.
relief, which we even haven't
Exactly.
paid attention to yet.
Exactly. And how you connect the wire, the flexible part to the
Hmm.
actual stiff connector pin or whatever, and where
Yeah.
you're going to get the strain relief. But then again, a lot depends on how it's working in your system, and it's like noise internally and things like that. Whether you've shielded it properly, the connector company or the wire manufacturer and connector manufacturer it can't be aware of that unless you give them the system.
Yeah.
And so
And
there's
even then, what my argument is it's rare. It's more and more rare that the vendor will have the resources to help you answer that question. They just we've cost reductions, and is you can make them, and we'll try to pick the right one. But I think in some components,
right,
especially commodity-ish type components, is that there's the it's we don't have the most experienced engineers working on those, even though they cause, say, 10% of your field problems. And
right,
I think that's where looking at components in, the brand new gee whiz 2 nanometer, this, that, and the other thing. Yeah, we need to pay attention to that. Will that actually work for us? And let's get it up before we get it in any products. Let's do our due diligence there. Yet don't lose sight of of connectors and capacitors and resistors and linear regulators and all these other parts that we use almost without a thought, they still cause field problems. And I think that's why I wanted to talk to you about connectors is it's we use a lot of them. They cause a lot of problems. We should
Yeah.
refresh that we should be aware of them and pay attention to them.
There's probably not a connector guy in most companies,
No.
but but you talk about not anybody having expertise in mechanical. It's it's an electrical system, but that's kind of all true with almost all electronic assemblies. It's a mechanical issue, like the underfill in a BGA.
Yeah.
The expansion and contraction of that has caused all kinds of electrical problems, even though it's a mechanical issue of
Yeah.
different thermal coefficients of
No,
expansion,
but
matching those and things.
yeah. Well,
So that
we can wrap this all up though, Kirk, by saying,
okay.
well, software can fix it later. Which we haven't even talked about
Yeah.
yet.
Don't think so. Not
No.
most of the time, not with connectors.
No.
But you grab another one, you plug it in, it works, you throw away the cable.
Yeah, and you totally forget why it failed or how it failed,
Or you
and
don't do any
everything.
inspection on it. You say,
No,
well,
you
that
don't
was
do
just
any
a
of that
bad
stuff.
one. But there
Yeah.
is a big difference between just general USB cables. I saw in a recent television show about looking in the inside, doing an X-ray of a Apple USB versus somebody else's USB-A, and they had amplifiers or they had components in the connector, whereas a cheaper manufacturer just has a straight wire connection to pretty
Yeah.
much everything.
And it might be just a force fit, instead of soldered or anything else. It could be just the wires close to the plate and it's kind of molded in place and then they hope it holds.
But people couldn't see the difference, and it would be hard to justify, whereas Apple cable was USB cable was $50, and you could find, the run of the mill USB cables for $15. It's, real hard to, unless you know that information about the quality or internal components or how it's built. I just grab whatever, and I've certainly gone through a lot of USB cables that have failed. Probably mostly because of strain relief.
Yeah. Yeah. No, it's a good point. It's, sometimes you get what you pay for, but it does take taking the time to understand it. What's the right cable and what's the right system for our application? It's not grab one off the shelf. If you've got a lot of long history with a product and you've been using this ribbon cable to connect your motherboard to the display, and you've got, evidence from your field results that that's okay, it'll eventually catch up to you because eventually we're going to design it into a laptop. Now that cable has to move and or we stretch the distance so the strain relief doesn't. We do something that removes all the margin, and now it
Right.
fails. It's something that it's true with all of our components, yet it's one that often gets overlooked, and for all kinds of reasons and all kinds of steps in the program. So that's why I wanted to talk to you about it, because I
Right.
know you've
Right.
dealt with connectors various
Oh,
times.
lots of times, yes. And
Uh,
it can be very frustrating
it can be, and
because
let's if you're the folks that are listening to this, it's do you have somebody that's the go-to internal connector person, or is it, uh, not an issue and, or is it creeped up as a problem every now and then and you realize that, yeah, it is a connector problem. It's kind of an informal survey, and one part is to say, hey, what do you see or do? How do you prevent cable issues would be the success story I'd really like to hear. Or if you've got questions about connectors, I've certainly, Kirk and I both have had plenty of experience dealing with them, trying to troubleshoot them and stuff.
right.
So, let us know how's connectors working for you and your electronics, and we'd be very interested to see how that's all working. But let us
Yeah.
know. Head over to accendoreliability.com/go/SOR. You can find a couple of ways to connect with us. Kirk and I and the other hosts are available through LinkedIn and our About pages. So plenty of ways to get connected to us.
Wait, wrap it up.
Yeah. Well, thanks, Kirk. We'll
Yeah.
see you later.
All right, Fred. Talk to you soon.
Yep. See you. Thanks for listening to Speaking of Reliability. We invite you to join the conversation If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.